Welcome. Today we're going to practice solving inequalities using multiplication or division. So first, we're going to run some little tests to see if we can multiply the same thing to both sides of the inequality and still end up with something that is true. So first up, we want to make sure we're starting with an inequality that is true. So here we have 7 is greater than negative 9. Is it true that 7 is bigger than negative 9? Yeah, that's true. So now we can go ahead and try multiplying both sides by the same number. So let's try multiplying both sides by 5. So remember, we do not want to use x anymore for multiplication. So you can use a dot if you want for multiplication, or you could use parentheses. So when we go ahead and do this, 5 times 7 will give us 35. We bring down the inequality sign, and negative 9 times 5 will be negative 45. So is it true that 35 is bigger than or greater than negative 45? Yes, that's true. All right, over here. Let's try multiplying both sides by negative 7. Here I'll practice using the parentheses for multiplication. So we have negative 7 times 7. And on the other side, we have negative 9 times negative 7. Well, when we multiply this, negative 7 times positive 7 is negative 49. We bring down the inequality sign. And over here, negative 9 times negative 7 is positive 63. Is it true that negative 49 is greater than positive 63? No, actually. A negative number is not going to be bigger than a positive number. So there's a problem here. We could fix this. To fix this, we just need to reverse the inequality sign. So we'll have it facing the 63 instead. So we would say negative 49 is less than 63. If we fix this, now it's okay. But if we do not reverse the inequality sign, then this isn't true. Let's see if this happens again with a different inequality. So here we have negative 3 is less than 10. That's true. That's a true inequality. Negative 3 is smaller than a positive number. Let's try multiplying both sides by 2. So I multiply the left side by 2, and I multiply the right side by 2. Well, 2 times negative 3 is negative 6. We bring down the inequality sign, and 10 times 2 is 20. Is negative 6 less than 20? Yeah, that's true. So that works. All right, over here, multiplying both sides by negative 11. So if I multiply the left side by negative 11, and I multiply the right side by negative 11, well, negative 11 times negative 3. Negative times a negative is a positive. 11 times 3 is 33, so this will be positive 33. We bring that inequality sign down, and 10 times negative 11 will be negative 110. So is it true that 33 is less than negative 110? No, this still isn't true. Again, in order to fix this, we have to reverse the inequality sign. We have to flip that around. So it wouldn't open towards the negative 110, it would open the opposite way, where 33 is greater than negative 110. And if we were to try this with other inequalities, or multiplying with other positive numbers or other negative numbers, we'll end up seeing the same repeating pattern. If we multiply both sides of an inequality by a positive number, we'll get a true statement. However, if we multiply both sides of an inequality by a negative number, we will always end up with a false statement unless we reverse the inequality sign. So over here, for question 3, therefore, whenever you multiply a number on both sides of an inequality, the resulting inequality is not always true. It is not true if you're multiplying both sides by a negative number. So when we have to multiply both sides by a negative number, we have to remember to reverse or flip the inequality sign. If we're multiplying both sides by a positive number, then it's true. So we only need to make sure to make this adjustment when we're multiplying both sides by a negative number. Next up, let's see if this holds true for dividing, or if dividing works a little more nicely for us. So first up, we have our inequality. 12 is less than 18. That's true. So let's try dividing both sides by 3. So the way we'll set this up is like a fraction, because remember the fraction bar means that we are dividing. So 12 divided by 3, that will give us 4. We bring down the inequality sign, and 18 divided by 3 will give us 6. Is it true that 4 is less than 6? Yeah, that's true. All right, what if we want to divide both sides by -6? So on the left side, I'll divide by -6, and on the right side, I'll divide by -6. Well, when we do this, 12 divided by -6 is -2. We bring down the inequality sign, and 18 divided by -6 is -3. Is it true that -2 is less than -3? No, this isn't true. So owing someone $2 is better than owing someone $3. So -2 is actually bigger than -3. So to fix this, if we have our -2 and our -3, the way that we fix it is we reverse which way the inequality sign opens up. So if we reverse it, then it will be correct. Let's check one more example. So here we have the inequality at 8 is greater than -12. Well, that's true. So we can go ahead and do some adjustments here. Let's try dividing both sides by 4. If we do that, 8 divided by 4 is 2. We bring our inequality sign down. -12 divided by 4 is -3. So is it true that 2 is greater than -3? Yeah, that's true. And lastly over here, let's try dividing both sides by -2. So 8 divided by -2, that'll give us -4. We bring the inequality sign down. And over here, -12 divided by -2, that will be +6. So is it true that -4 is greater than 6? No, that's not true. A negative number cannot be greater than a positive number. So we have a fix for this. All we need to do is reverse that inequality sign, have it open up to the right instead of the left. So our inequality will become -4 is less than 6. And if we do this, then it is correct. So just like with multiplication, when we divide, if you divide both sides of an inequality by the same number, it is not always going to be true. If you're dividing both sides by a positive number, our resulting inequality will be true. However, if you're dividing both sides by a negative number, you will have to reverse the inequality sign or flip the inequality sign in order to get a correct inequality. Let's look at a few practice problems together where we can practice solving inequalities and we can practice graphing the resulting inequalities. So on the back of the page, we have a few examples to solve. So first up, we have -12 is less than or equal to b plus 3. Well, to solve the inequality, we need to get the variable by itself. So to get rid of this plus 3, I can get rid of that plus 3 by subtracting 3 from both sides. So -3 minus 3, that will give us -12 minus 3 is -15. We bring down that inequality sign and we have the variable b. So if we want to graph this on the number line, I know that I need to make a circle at -15. Because b is greater than or equal to -15, b could be the number -15. So that means I need to shade in my circle here. And lastly, to decide the direction that I draw the arrow in, since b is greater than or equal to -15, it opens up towards the variable. That means b can be numbers larger than -15. Well, larger numbers are found to the right side. So we will draw our arrow going off to the right side. For the next example, x minus 6 is less than 17. To get x by itself, I have to get rid of this 6. I can do that by undoing subtraction, by adding 6 to both sides. So when we do that, on the left side we will just have x. On the right side, 17 plus 6 will give us 23. So to graph this, I will need to place a circle at 23. Since this is x is less than 23, there is no equal to part. I will leave this circle open or unshaded. And since this inequality opens towards the 23, that means x has to be a number smaller than 23. So smaller numbers are off to the left side of the inequality. So I'll draw my arrow going off to the left. Next up over here, 20 is greater than or equal to negative 5d. Well, to solve this, we need to get d by itself, so we have to get rid of this negative 5. We can do that by dividing both sides by negative 5, since right now they're being multiplied together. Negative 20 divided by negative 5 will give us negative 4. On the right side, negative 5d divided by negative 5 will cancel out. So we're left with d, and we need to make sure to reverse the inequality sign because we divided both sides by a negative number. When it's time to graph, we'll put a circle at negative 4. Since d is greater than or equal to negative 4, d could equal this number, so we will want to shade this in. And since this opens up towards the variable, d could be numbers larger than negative 4, so we would draw our arrow going off to the right side. For our next set of examples, m over 4 is greater than negative 8. We can go ahead and solve for m by getting rid of this negative 4. Right now, m and 4 are being divided, so we can undo that division by multiplying both sides by 4. When we do that, times 4 divided by 4 will cancel out. So we're left with the variable m. On the right side, negative 8 times 4 is negative 32. And because I'm multiplying both sides by positive 4, I do not need to worry about reversing the inequality sign. If we multiply or divide both sides by a positive number, our inequality will still be true. So I can go ahead and graph this. I have 0 on the number line. I'll put negative 32 to the left, positive 32 to the right. I can go ahead and place a circle at negative 32. There is no equals to part here, so I will leave this unshaded. And since m is greater than negative 32, m could be numbers larger, so I'll go ahead and draw my arrow going off to the right. Here, 6h is less than or equal to 18. We can go ahead and solve this by getting rid of the 6. So we can do that by dividing both sides by positive 6. 6 divided by 6 will cancel out, so we have h on one side. On the other side, 18 divided by 6 will give us 3. Now, since I'm dividing both sides by positive 6, I do not need to change the direction of the inequality sign. If I was dividing by a negative number, then I would. But since this is positive 6 that we're doing to both sides, we do not need to worry about that. So I need to graph h is less than or equal to 3. So I'll have 3 on the right, 3 on the left. I need to place my circle at 3. Now, because this is h is less than or equal to, h could equal 3. So I'll go ahead and shade this in on the number line. Now, h could also be numbers smaller than 3. Smaller numbers are off to the left side, so I'll draw my arrow going to the left. Next up, number 6. Negative 3 is less than k over negative 3. Well, we need to get k by itself, so to get rid of this negative 3 on the same side, k is right now being divided by negative 3, so we can cancel that out by multiplying both sides by negative 3. So when we do that, times negative 3 divided by negative 3 cancels out, so we're left with k on the right side. On the left side, negative 3 times negative 3 gives us positive 9. Now, because I'm multiplying both sides by negative 3, we need to reverse this inequality sign. So it will not open up to the right. Instead, we'll flip it, so it'll instead open to the left. If we do not make that change, our resulting inequality will not be accurate. So now we can go ahead and graph the inequality. I have 0, 9, and negative 9. I will put my open circle at 9. 9 is greater than k, so that means k has to be numbers smaller than 9. So smaller numbers are off to the left side of the graph. So I can draw my arrows going off to either side. As a reminder, just like what I'm doing here, if it's difficult for you to clearly show the arrows or which side you're going to on the number line itself, you can always draw it just above the number line. Just make sure that your circle is very clearly marked for wherever that is on the number line. Lastly, we have 2 examples of word problems here. let's go ahead and practice setting up the inequalities for these. You'll have a chance to solve them on your own. So this says Gina's pet potbelly pig is on a diet. He can have no more than 18 ounces of pig food per day. How many scoops of pig food can Gina feed the pig without going over 18 ounces? Well, over here we're also told that there's 4 ounces per scoop. We know that the pig can have no more than 18 ounces of pig food. So that means he could have 18 ounces of food in a day. He could have smaller than that. He could have 10 ounces or 16 ounces or 15 and a half ounces. But he cannot have more than 18 ounces. So he cannot have 19 ounces, 100 ounces, or like 18.1 ounces. That's all too much food. So if we have 18 sort of as the limit, and over here we're trying to represent how much food the pig is eating that day, it has to be less than 18, or it could equal 18. Now it asks how many scoops of pig food Gina can feed. So when we define this, let's say let x equal the number of scoops. Well, we can see that it is 4 ounces per scoop. So if we gave 1 scoop, that would be 4 ounces that the pig ate. If we gave 2 scoops, that would be 8 ounces. 3 scoops would be 12 ounces, and so on. So you can take the number of scoops and multiply that by 4 ounces, and that will tell you how much food the pig ate that day. So we would say 4 times x being the number of scoops. So we can go ahead and solve this inequality by getting rid of this 4. We can undo 4 times x by dividing both sides by 4. So 4 divided by 4, we will have x on the right side. 18 divided by 4 will give us 4.5. Now because I divided both sides by positive 4, I do not need to reverse the inequality sign. So we can say Gina can give less than or equal to 4.5 ounces, or sorry, not 4.5 ounces, 4.5 scoops of food. There you go. Another way that you could phrase this is you could say Gina can give no more than 4.5 scoops of food. That also works. Or Gina can give at most 4.5 scoops of food. So there are different phrases that you can use to communicate this idea of less than or equal to. All right, let's look at this last example here. Vana is saving for a trip. The hotel room will be $298.17 for 3 nights, and there will be additional fees. What is her daily cost? Well, we don't know what her daily cost is. That's what we're trying to find. So we can define our variable. So we can say let x equal the daily cost. So this will include all fees, all payments she has to make for that day. So right now, we know that it's this amount of money, almost $300 for 3 nights. So the way we can figure out her daily cost is, or the way we can figure out how her daily cost impacts her total fees, we know her daily cost will occur each day, since she's going there for 3 nights or 3 days. That means whatever her daily cost is, multiply that by 3, and that will give us that will help us figure out what her daily cost is. That will end up totaling this much or more, because it says this is just for the hotel room. She's also going to have to pay probably for for lunch or dinner or some other sort of fee at the hotel. So we know that her daily cost is not going to equal 3 times some number that will give us $298.17. It's going to end up being more than that. So really, this 3 times X is going to end up being bigger than the fees for just staying at the hotel for all 3 nights. So we would say that 3X is bigger than $298.17. Now, to figure out that exact amount, we could go ahead and divide both sides by 3. So we will get X on one side. On the other side, you'll end up getting 99.39. And since I'm dividing both sides by positive 3, I will keep the inequality sign the same. If I divided both sides by negative 3, then I would need to reverse the inequality sign. So we can write our answer as a sentence. We can say her daily cost will be more than or greater than $99.39.